Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the reaction sequence. Starting material, CH3CCH, propyne methylacetylene. Moving on to the next step. Treatment with 9H2 deprotonates the terminal alkyne to form the acetylide anion CH3CC-Na+. Moving on to the next step. Treatment with CH3I, alkylation of acetylide, gives CH3CCCH3I to butane, an internal alkyne. This is compound A. And for the final step, hydrogenation of 2-butane, CH3CCCH3 over PDCaCO3, Lindlar's catalyst, gives SYN addition of H2 producing CIS2-butene, Z2-butene. This is compound C. Identify compound B. The question asks about the relation between B and C. In the context of this problem, B is the product of reduction of 2-butane under different conditions, specifically with Na liquid NH3, Birch type, dissolving metal reduction, which gives trans 2-butene, E2-butene, via anti-addition. Although B is not explicitly shown in the cropped image, the standard paired question involves B is equal to trans 2-butene from Na NH3 reduction. Relationship between B trans 2-butene and C CIS2-butene. Both have the molecular formula C4H8 and the same connectivity, but 2Na, so they are stereoisomers. They differ in the spatial arrangement of groups around the C is equal to C double bond, one is CIS Z and the other is trans E. Because of the restricted rotation about the double bond, they cannot interconvert without bond breaking, making them geometrical isomers, a type of stereoisomerism with restricted rotation. They are also diastereomers, stereoisomers that are not mirror images of each other. Geometrical isomers, CIS trans about a double bond, are a subset of diastereomers. Therefore, B and C are simultaneously geometrical isomers, option C, and diastereomers, option B, since geometrical isomers are a specific type of diastereomers. Why not A, enantiomers? Enantiomers are non-superimposable mirror images. CIS and trans 2-butene are not mirror images of each other. Why not D, meso? Meso compounds contain stereocenters, but are achiral due to internal symmetry. Neither CIS nor trans 2-butene is a meso compound in the classical sense of that term, they lack stereocenters. Both B, diastereomer and C, geometrical isomer correctly describe the relationship, as geometrical isomers are a subclass of diastereomers. Therefore, the correct answer is B, C. The correct answer is shown on screen.